Service robotics continue to increasingly play an important part of our everyday lives. Yet, many of us lack the knowledge about them, especially what is required to design a system that fits inside one. Hi, my name is George Harriman, and I am a systems architect with ROHM Semiconductor. Today, I will be presenting an overview of various electronic building blocks that make up a service robot and introduce some of ROHM's products that support the design of robot systems. Some examples of service robots that are popular include robot vacuum cleaners that has helped many of us clean our homes better with their elaborate mapping functions, drones that are used by vloggers to create stunning aerial videos of nature's beauty, by industrial and agricultural surveying technicians to gather data on project sites and farms or fields. And finally, retail and social robots seen roaming around in restaurants and public service buildings such as airports, libraries, and other places. They truly are becoming part of our everyday lives. Service robots require various functions to perform their duty, and the majority require electronic building blocks. From internal functions that may not be as apparent from the outside, such as battery management, power management, and memory, to functions that allow the robot to maneuver, such as motor drivers, mapping functions, and situational awareness functions. Other essential functions such as connectivity to the network and additional features such as speech synthesis allow the robot to interact with the human world that they are supporting around them. Every service robot will require some form of communication to its environment. Depending on the range, various technologies are employed. For service robots that work inside an office or factory setting, high-performance Sub-GHz technology is the most optimal. Lapis Technology, a ROHM group company, offers Sub-GHz SoC, MCU, and also ROHM offers a Wi-SUN module that includes not only the SoC and MCU, but other peripheral chips on the same board. Lapis's Sub-GHz wireless solutions has 4 features. 1. Environmental resistance, meaning stable communication is possible even outdoors, regardless of the season. Voltage and temperature dependence of transmitter power, receiver sensitivity is minimized, ensuring stable communication range. 2. High RF performance, meaning employing functions such as antenna diversity and forward error correction, or FEC. These combined allow stable communication perception. 3. Lower power consumption, meaning combined with auto wake up and sleep functions, the chip can detect a received signal of about 1 millisecond duration. With this low power consumption, operation is realized. 4. Worldwide support, meaning our products cover frequency range globally. Here are some examples of different applications that uses Sub-GHz, Wi-SUN, and Low Power Wide Area Network, or LPWAN. Various different part numbers from Lapis can cover different end applications. For service robots, part numbers such as those used in home area network, smart factory, and smart building is suited and is recommended. Some of these products, such as the ML7346N, also includes Wi-SUN capability inside. This is the BP35C5 module, which comes with a built-in Wi-SUN fan software stack, reducing design development efforts. The BP35C5 is Wi-SUN certified and radio law certified by the Radio Act of Japan and the US. Therefore, it can be used immediately. The BP35C5 comes in a module that is shielded for RF signals, making it more reliable and minimizing loss of communication. It can connect up to 100 units using only BP35C5 modules, increasing the coverage distance. It is very good obstacle resistance, provide fast communication supporting selectable speeds of 50 kilobits per second, 150 kilobits per second, and 300 kilobits per second. Additionally, there is not monthly running cost for the service. Accelerometers can be used to detect various kinds of motions in a robot system. The above shows some examples such as detection of angle, vibration analysis, detection of motion to wake up a system, detection of shock, and also free fall detection. A service robot that is used to deliver meals in a restaurant may employ these type of detection to ensure safe delivery of the food to the tables. Both KX132-1211 and KX134-1211 products are intended for industrial applications. It is rated up to plus 105 degrees Celsius operating temperature, has fast 25.6 kHz output data rate, has built-in vibration detection engine, and has low standby current of only 0.5 microamps, as well as low operating current with a minimum of only 0.53 microamps. The KX134-1211 can measure acceleration up to plus minus 64 Gs. The lineup of ROHM's accelerometers consists of three different part numbers. The KX TJ3-1057 is targeted towards consumer application, while the KX132-1211 and KX134-1211 are targeted for industrial applications. The range of acceleration detected covers from 2 Gs up to 64 Gs. All parts have digital interface and comes in space savings 2x2mm LGA package. All product features either I2C or SPI I2C standard digital interface for easy communication to a microcontroller. Visit the Chionix website to learn more about these products. Evaluation kits and development boards for ROHM's accelerometers are readily available for purchase on various distribution websites. It is highly advised to purchase these eval kits in order to quickly evaluate the performance of ROHM's products. Please visit the support website shown on this slide for more information about these eval kits. Various motors are used in service robots. For example, three-phase brushless motors are used for motion and movement of higher loads, while stepper motors may be used for motion that require precision control. ROHM's solution for three-phase BLDC motors has advantages mainly in the control methods, such as supporting wider voltage range by the ability to drive external MOSFETs, and employing constant current drive for reduction of component counts. ROHM's stepper motor driver has different drive methods and stepping size, allowing micro-stepping for fine motor control. Brushed DC motors are used in mainly rotational motor applications with low to medium power. Such motors may be used in a robot vacuum cleaner's wheels and side brushes. The product lineup for ROHM's high-voltage DC brush motor driver covers 36 volts and 50 volts apps max supply voltage from 0.5 amps to 5 amps drive current, and 1-channel to 2-channel drivers. Many products are pin-to-pin compatible with each other, thus making it easy to scale a design without the need of changing the PCB layout. Stepper motors may be used in a robot where precision and stopping position is important, such as robotic arms and other precise movement auxiliary portion. The product lineup for ROHM's stepping motor driver covers 36 volts max supply voltage from 1 amp to 4 amp current drive, with step sizes from full step to 1/16th step, and with input interface using direct clock-in mode or the traditional parallel in mode. Some part numbers are even more flexible and cover both types of input interface. The BD63910 MUV and BD63920 MUV comes in a small size 5x5mm QFN package. Brushless DC motors or BLDC are used where higher power is required compared to a brushed DC motor. The suction motor on a robot vacuum cleaner, as well as the propellers on a drone, may be using brushless DC or BLDC motors, as these require more power. The product lineup for ROHM's 3-phase BLDC motor driver covers both 122 degrees and 180 degrees commutation drive, with products that have internal integrated FET, i.e. the driver type, as well as those that drive external FETs for higher power operation, i.e. the pre-driver type. For motor drivers that drive external FET, ROHM offer many N-channel as well as P-channel MOSFETs. The latest generation 6 of N-channel MOSFET as well as generation 5 of P-channel MOSFETs are targeted towards middle power with MOSFETs up to 150 volts rating. Various features such as compact high-power packages as well as lower RDS(on) products offer system designers a choice of power devices to design efficient and compact motor driver solutions. Laser diodes are used to shine laser with high power and focus directionality for the purposes of measuring distance, object detection and avoidance, and mapping functions including such as 3D scanning and LiDAR, or light detection and ranging. Depending on the usage, different wavelengths of lasers are used. For service robot application in particular, the main function of laser diodes is for room or area mapping such as that found in robot vacuum cleaners, and object avoidance and collision prevention for other moving robots in general. ROHM contributes to high resolution and longer range of LiDAR with 4 features. 1. Narrow emitting width. 2. High power conversion efficiency or PCE, meaning ROHM has good efficiency over a wide current operating range. 3. Small temperature dependence of wavelengths, meaning ROHM achieves smallest temperature coefficient and wavelength shift compared to other vendors. And 4. Uniform optical intensity, meaning ROHM laser diode has greater than 90% intensity across the entire distance up to 225 micrometer. All these features allow LiDAR to have high resolution shape, high efficient longer range, and clean edges of the reconstructed picture. This table shows the product lineup of ROHM's laser diodes that cover from 630 nanometers to 950 nanometers. Products that produce light above 740 nanometers are generally not visible to the human eye. Each wavelength grouping is targeted towards different end applications. For robotics, the range from 650 nanometers to 670 nanometers can be used as fine particle detection. The range from 780 nanometers to 800 nanometers for ranging and mapping functions, while those above 800 nanometers are used for motion sensing and time of flight application. Visit the web page link shown above to view a more detailed lineup. Robot vacuum cleaners employ SLAM, or simultaneous localization and mapping modules, to measure distance of surrounding objects and creating maps to guide itself around the house. Laser diodes of 780 nanometer wavelengths can be used by way of triangulation or direct time of flight method. Higher power laser diodes at higher wavelengths can also be used for larger distances. Ambient light sensors are used to detect the intensity of the environment ambient light in order to then adjust other functions in the robot, such as display brightness or other lighting brightness. ROHM's ambient light sensor has high infrared light removal rate, which allows accurate detection. ROHM has both analog and digital type of ambient light sensors. Some of ROHM's ambient light sensors employ infrared cut filters, allowing use in dark or narrow window operation as shown in the picture above. Color sensors are used to detect the color temperature and hue, in addition to illuminance for color discrimination of products or auto-white balance for a camera. Robots that can detect color will be able to perform object detection beyond just shapes and make for a more intelligent robot. ROHM's digital color sensor offers 16-bit serial output. This is the product lineup for ROHM's ambient light sensor IC and color sensor IC. Ambient light sensors come in both analog and digital output, with detection ranging up to 100,000 lux. An interface with I2C of linear and logarithmic output current. Color sensor comes in digital output type with I2C interface and detection range up to 80,000 lux and having infrared cut filter built in. ROHM's Sensor Shield EVK003 is compatible with open platforms such as Arduino Uno and Mbed. The Sensor Shield enables easy evaluation of many onboard high-performance sensors, making it ideal for verifying sensor operation, initial set development, and as a learning or training tool. The optical sensor mentioned in this presentation can be evaluated by using Sensor Shield EVK003 board. More information about this EVK can be obtained by visiting the webpage link shown above. Robots in general may not need the ability to speak. Service robots, on the other hand, really benefit in having this function to interact with humans who operate or use them. Some of the benefits of introducing speech or voice into the system include alerting users and operators, better information delivery beyond just text or display, feedback confirmation by voice gives assurance to the operator, and voice status notification is more pleasing than just ordinary notification by blinking lights. Lapis Technology, a ROHM group company, has provided speech synthesis LSIs that enable immediate high-quality sound playback in everything from home appliances to automotive systems. These sound playback LSIs feature an all-in-one configuration that integrates all necessary function into a single chip, enabling high-fidelity sound playback by simply connecting a speaker and sending simple commands from an MCU. Our chips provide simple-to-use functions, including fault detection and reduction of external components needed by integrating speaker amplifier, memory, oscillator circuits, and others. This is the product lineup of our ML22XXX series of speech synthesis LSI products. They feature a various playback duration time, built-in 1.0 watt speaker and amplifier, high-quality sound and high-compression algorithm, onboard flash memory rewrite functions, and various failure detection functions to provide a robust solution. For more speech synthesis-related products, including speech playback MCUs, please visit the link as shown above. Memory is an essential part of any electronic system. ROHM has a wide range of EEPROM, or electrically erasable programmable read-only memory, which is a type of non-volatile memory. EEPROMs are used to store data such as program instructions and other important information that will remain even if power is lost. ROHM's EEPROMs products have various advantages such as high-speed write with the ability to write in 3.5 milliseconds, high number of rewrite achieving 4 million cycles, the ability to be operated even at very low voltages down to 1.8 volts, and the availability in small packages such as WLCSP or wafer level chip scale packages, allowing for compact board design. The product lineup of ROHM's EEPROM spans both consumer grade and automotive or AEC-Q100 grade. Various series in each lineup support operation with different communication interfaces such as I2C bus, microwire bus, and SPI bus, making it versatile in any system. High reliability is ensured with error correction code or ECC to ensure correct data is written and read from the EEPROM itself. Memory density spans from 1 kilobits to 1 megabits. For detailed product lineup and part numbers, please visit the webpage in the link shown above. Today's portable electronic devices, including service robotics, all utilize some kind of battery as the main power source. Lithium-ion batteries increasingly is the popular choice due to their high energy density. However, lithium-ion batteries operation needs to be monitored carefully as this type of battery does not tolerate well any stresses such as overvoltage and overcurrent. Battery Monitoring IC or BMIC offers various functions such as protection from abnormal voltage, abnormal current and temperature levels, as well as the ability to predict battery levels for more effective use of the battery capacity. Depending on the end application, different voltage level is needed and thus different battery configuration are used. Light industrial tools such as power tools or cordless vacuums may only have 3 series battery for voltage levels around 11 volts. Higher power industrial tools such as robots may employ 5 or more batteries in series. Robots may be using many more cells. In the above example, 14 series cell. The full product lineup for lithium-ion battery monitoring IC or BMIC is shown above. For service robotics, the BMIC part numbers of interest are those that cover the range of cells up to around 14 series cell. The products that are marked AFE only have the analog front-end circuits inside and will need to be driven by an external MCU to do further detection logic via I2C or SPI interface. The products that are marked as A are standalone products that do not require any MCU interaction, as these products have internally built circuits for the detection logic. Some products also include internal FET driver and cell balancing FET. Visit the website link shown above to learn in more detail the various offerings of our BMIC products. ROHM's DC-DC buck has many advantages. One main feature to highlight is our nano pulse operation that allows switching operation at very high frequency to reduce magnetic sizing while being able to still convert from very high voltages down to very low voltages. This is achieved with the capability to operate down to 9 nanoseconds on time, allowing conversions from 60 volt input down to 3.3 volt output at 2.1 MHz switching frequency. Conversion using only one step from high voltages down to low voltages will result in high efficiency as it avoids the need of a second intermediate buck converter stage. Another feature is nano energy, with one of the lowest current consumption when compared with other vendors. This allows systems to operate at higher efficiency levels. Every system requires DC to DC power conversion. Many robots operate from a battery voltage that ranges up to 28 volts and beyond, which needs to be converted down to various power rails to supply power to various onboard systems. ROHM's BD9X series of part covers efficient buck switching DC to DC power conversion from 2.5 volts to 100 volts input voltage with output current capability from 0.5 amps to 8 amps. The naming nomenclature shown on this page indicates the various voltage range in the family. There are many evaluation boards for the BD9X family available for purchase. The 5 above are the BD9AX, BD9BX, BD9CX, and the BD9FX family. More EVKs for other part numbers are also available for purchase, and information can be found on the website link shown above. Thank you for your time. Please visit our website and consider evaluating the products mentioned in this presentation by checking out our evaluation boards.